Ladies and gentlemen, did you all prefer on having a high tensile strength material with the cheapest price? Have you all worried that materials with holes will fail easily? Have you all used the carbon and glass fiber, and did you all get impressed with their benefit? Do you all prefer if a material is created having a proper piece of the both glass and carbon fiber? If yes, then this research will be suits for you all. A very good day everyone. I'm Devan from Bachelors of Mechanical Engineering Department of Unisel here to present regarding my FIBRE, which titled by Tensile Properties of the Carbon Glass Fiber Hybrid Composites with various fiber orientations and hole features. Shall I start? Ladies and gentlemen, here is the outline of my presentation today. Initially, let me have a look on the problem statements. Glass fiber was known to be cheap, light in weight, chemical resistant, but it has a poor tensile strength, brittle fracture characteristic, and high density. While the carbon fibers are tough, robust, lightweight, have a great tensile strength, ductility, and low density, but it's expensive. As a result, carbon fiber was hybridized with the glass fiber in this research to improve the tensile strength of the glass fiber. Moreover, in practice, composite materials are frequently used in fabrication process where necessitate drilling activities which leads the specimens to damage and become destroyed. Damaged specimens do not necessarily mean they cannot be used. They may be damaged, but they have not yet failed or shattered. As a result, the value of the damage resistance and the damage tolerance of the hybrid specimens at various orientations will be established in this investigation. Moreover, in the majority of the previous studies, only circular holes are analyzed. However, various hole features were used in machining and joining process in real applications. Thus, this study was carried out with various hole features to identify the tensile strength. Ladies and gentlemen, now let me go to the objectives of this study. First, to investigate the influence of the different orientations on the tensile properties of the carbon glass fiber hybrid composite. Second, to analyze the effect of hole features on the tensile properties of the carbon glass fiber hybrid composite. Finally, to observe the fractured surface specimens. Now, let me have a look at the methodological part. Initially, the prepreg carbon and prepreg glass were cut off and it will lay up on the aluminium plate based on the required orientations by using hand layup method. Followed by that, the orange prepreg laminates were cured by using vacuum bagging and by forced air convection oven. Once the specimens were prepared, it was cut by using the jigsaw cutting machine. Then various holes such as circular, diamond, triangular, rectangular, and square holes are made. These images shows that the various orientations which have been used, and this picture shows the various holes which have been used. Then the tensile test will carry on. Now let me look on the result and the discussions. Ladies and gentlemen, based on your knowledge, which orientations do you all think will give a great tensile strength? This data here clearly shows that the 90-degree orientation record the higher values in all the results. This data shows that 90-degree orientation record the maximum tensile strength because orientation is perpendicular to the direction of the force applied. Thus, it withstands the larger tensile strength while 0-degree orientation record the lowest because it's parallel to the force applied. So, it only withstands the lowest tensile strength. Moreover, higher modulus of elasticity was also analyzed in 90-degree orientation. From the graph, the modulus of elasticity was also recorded large differences because of the various orientations used. Subsequently, tensile properties of the hand hole and circular hole features with various orientations is discussed in this part. Obviously, it shows that the whole specimens will affect the tensile result. From this table, we can find that 90-degree orientations recorded the higher values in all the categories, but 0-degree orientation recorded the lowest result in all the categories. Followed by that, from this data, it was observed that the square hole specimens recorded the higher tensile strength, while the triangular holes recorded the lowest. This is because surface stress concentration is higher at the sharp edges compared to the square cross-sectional. Triangle cross-section has a sharper edges. That means it has a higher chances to failure. Thus, it breaks too fast and recorded the lowest tensile strength. In addition, higher tensile strength was recorded by the rectangular hole specimen. The lowest tensile strength was recorded on the triangle hole. Moreover, the recorded modulus of elasticity values shows very significant differences because of the usages of same material, same density, and same orientations. Not this only, comparisons between the whole and Humboldt specimens were also made to further investigate the tensile properties. As shown in the figure, the tensile strength value for the Humboldt specimens were higher as compared to the whole specimens. Based on the data, the maximum value of the tensile strength were recorded in Humboldt 90 specimen, while for the whole specimen, maximum tensile strength and the damage tolerance is recorded in the square hole. Moreover, based on damaged observations, brittleness characteristics of the glass fiber leads to the specimen's failure. Based on the findings, the holes which have sharp edges are fractured first compared with the normal edges, and we can also say that fractures occurs at the sharp edges of the holes. Last but not least, as a conclusion of my research, various orientations and hole features affects the tensile properties of the carbon glass fiber hybrid composite. As a best orientation, 90 degree was chosen because the tensile force applies perpendicular to the direction of the fiber arrangement. In addition, as the best hole feature, square hole was chosen since it recorded the higher tensile strength because of its less sharp edges. Finally, based on the visual observation on fractured surface, it was concluded that the holes with the sharp edges crack first and the cracks are happen at the sharp edges of the hole. Ladies and gentlemen, that's all from me. Thanks for listening.